first of all, when you have students or postdocs in your group who join and are really interested in getting started with machine learning, how do you recommend that they start out?
Well, first you want to pick a good problem, something that is going to, you want to study something where you can collect a lot of data. That is a central prerequisite. You want to tackle a problem that solves a field-wide challenge, okay? Which often means that you don't start off by just going off and collecting a whole bunch of data, but you go off and try to come up with a really great motivating example. So you build something where it might not work at all, but you identify and you know exactly why it doesn't work. And it's important, the reason why it didn't work. And or give you, now when I say doesn't work, I mean like gives you an unexpected result.
Right. Okay.
And for I don't want to give too many examples, but I mean, if you're, let's say, here's one example: you've engineered a metabolic pathway, you accidentally you use synonymous codon optimization, and there's a highly translated internal start codon in the middle of this enzyme coding sequence, and you throw it in and you express it, and you run a protein gel. And you see, oh my God, there's two big gigantic bands. I only expected one. Okay. Maybe it was, both were tagged. Okay. So that was an unexpected result. And then you go off and say, oh my God, there's a big start codon in there. It's being translated. That happens all the time. And it does. And so this is, we developed a solution for this with an algorithm to remove highly translated internal start codons. But it was something that, you want to pick a problem that it's not yet another learning model. It's an actual problem, right? So you want to work backwards from the problem.
Do you have any sort of specific practical advice about places to look for resources or like examples that would be good as introductions?
My lab and many other labs now export all of their data as supplementary data, tabular, sheets, CSV or Excel format, which means that you don't need to write code to read a PDF to extract numbers, which is good. So it's gotten better over the years that more people, publish their the data in which they actually used to develop their stuff, and which means that if you're going to test out an idea, it sometimes is just certainly more straightforward to go off and see if anyone has done any measurements related to that idea. Just go see if it works, even if like your idea, when people do an experiment, they only do that experiment to test their idea, not your idea.
But there's a lot of data out there, yeah.
But there's a lot of data out there. So what you would expect to see is that if you were to use other people's data, so OPD, you're not going to get the design of that data set was not 100% conducive to answering your random question, right? But you could still use it to see whether the inkling of the answer is there. Whether, there's enough information, enough pattern that you say, all right, my hypothesis is probably true, but now I know if I design a better data set, if I perturb the interactions that I care about more, systematically compared to that original data set, then I'll probably will get an even better answer. Again, has nothing to do with the quality of OPD, has more to do with you design a set of sequences or you design a set of perturbations to answer, to nullify or answer a hypothesis, but it's specific to a hypothesis, right? Usually, or a class of hypotheses. And if you change the question, oftentimes the data set is not going to be perfectly matched, but at least it can give you a little bit of an inkling whether or not it's worth your effort and time and money to go off and design a better data set and set of experiments to answer the question more fully.